The sun has risen every day for more than 4 billion years, long before the first human looked up at the sky. Before Earth had forests or oceans filled with life, the sun was already there, burning steadily, reliably, without pause. It has never failed to appear. It has never arrived late. It has never dimmed without reason. Civilizations have collapsed beneath its light. Species have gone extinct beneath its warmth, but the sun itself has always remained unchanged. Until one day, when it didn't. At first, nothing feels wrong. The sky still brightens at dawn, the daylight still feels familiar, shadows fall where they always have. People wake up, check their phones, go to work, complain about the weather, unaware that the most important object in their existence has begun to move. The shift is so small that no human sense can detect it. No instrument designed for everyday life would ever notice, but astronomers do. And the moment they see the numbers, their blood runs cold. The sun is drifting. Not dramatically, not violently, but unmistakably. Its position is off by a fraction so small it would mean nothing unless you understood gravity. The sun is not supposed to drift. It is the anchor of the solar system, the gravitational heart that everything else revolves around. If the sun is moving, then something far more massive must be pulling it, something unseen, something dark. Black holes are not rare. Astronomers estimate that millions of them wander through the Milky Way alone. They are born from dead stars, collapsed so completely that their mass crushes space-time itself. They emit no light, they reflect nothing. They do not glow or burn or announce their presence. They move silently through the galaxy like cosmic ghosts. Most pass through empty space forever, never touching anything, but not all of them. And eventually, probability catches up with everything. At first, scientists suspect a measurement error, a calibration problem, a software glitch. Data is checked, rechecked, and checked again. Different observatories around the world confirm the same result. The sun is accelerating, very slightly, very steadily, as if something far beyond the edge of the solar system is tugging on it with invisible hands. The equations narrow the possibilities until only one explanation remains: a massive object with no detectable light signature, a gravitational force without a visible source. A black hole is entering the solar system. When the announcement is made public, it sounds harmless, abstract, almost boring. The black hole is still incredibly far away, hundreds of times farther than Pluto. It will not reach the inner solar system for decades, maybe longer. There is no immediate danger. Life on Earth continues unchanged. The sun still shines, the seasons still pass. But beneath the calm language of press releases and interviews, scientists are quietly running simulations that end the same way every time. There is no defense against a black hole, no technology that can push it away, no explosion powerful enough to alter its path, no strategy, no emergency plan, no escape route. Humanity has only one option: watch and wait. The outer solar system feels the black hole first. Distant dwarf planets begin to drift from their ancient paths. Orbits stretch and distort, warped by a gravitational influence that should not exist. Pluto no longer follows the same lonely loop it has traced for billions of years. Neptune wobbles. Uranus tilts further, as if recoiling from something unseen. Still, the black hole itself remains invisible. It does not glow, it does not cast a shadow. It reveals itself only through absence, through the way stars behind it bend and smear into curved lines of light. Years pass. The black hole moves closer. The sun's motion becomes undeniable. It is no longer merely drifting, it is responding. The sun begins to orbit something, not cleanly, not gracefully, but unmistakably. The planets follow, dragged along like debris caught in a current. The solar system is no longer a stable structure, it is becoming a prisoner. On Earth, subtle changes begin. Astronomical calendars require constant correction. Long-term climate models stop matching reality. The sun's path across the sky shifts by fractions of a degree. Nothing dramatic enough to cause panic, yet. But those who understand orbital mechanics know that stability has already been lost. The countdown has begun. When the black hole reaches the realm of the gas giants, the universe finally reacts in ways that can no longer be ignored. Jupiter is the first to suffer. Massive beyond comprehension, Jupiter has acted as Earth's shield for eons, capturing asteroids and comets that might otherwise ended life on this planet. But Jupiter is still nothing compared to a black hole. As the black hole passes close, Jupiter's immense atmosphere stretches outwards, pulled into long, glowing streams. Hydrogen and helium tear away, heating as they fall, shining blue-white against the darkness. For a brief moment, Jupiter becomes the brightest object in the sky, glowing like a false star. Then its structure collapses. The planet is consumed, shredded into an accretion disk spiraling around its destroyer. From Earth, people see a brilliant new point of light appear in the heavens. Some cheer, some celebrate. Astronomers shut down their observatories and weep. The destruction of Jupiter destabilizes everything. The asteroid belt loses its gravitational balance. Rocks that have circled peacefully for billions of years are released. Some are flung outwards into interstellar space. Others fall inward, towards Earth. The sky fills with fire as impacts become frequent. Entire regions are erased. Oceans boil near impact zones. Ash and debris darken the atmosphere. The sun's light dims, not because it is dying, but because it is being pulled away. As the black hole draws closer to the sun, reality itself begins to unravel. Space-time warps visibly. The sun's outer layers stretch towards the darkness, forming immense arcs of plasma that spiral away. The sun screams, not in sound, but in radiation. Fusion within its core destabilizes. The steady nuclear fire that has powered life on Earth flickers. Temperatures on Earth plummet. Crops fail. Ecosystems collapse. The oceans begin to freeze from the surface downward. Yet Earth does not die quietly. The black hole's gravity captures the planet, pulling it into a terrifying dance. For a brief, horrifying period, Earth orbits the black hole itself. The sky becomes unrecognizable. Stars stretch into glowing rings. Time behaves strangely. Auroras spread across the entire planet, painting the sky in violent greens and purples. Radiation pours down as Earth's magnetic field weakens. Technology fails. Power grids collapse. Cities go dark. Humanity gathers outside, watching the sky together for the last time. Then comes the final moment. The sun, stripped and destabilized, spirals inward. What remains of its mass forms a blazing disk around the black hole. For an instant, the solar system has two suns, one of light, one of darkness. Then the light disappears. The sun crosses the event horizon. It does not explode. It is not destroyed in any dramatic sense. It is erased. With the sun gone, the solar system ceases to exist as a system. Some planets are flung away, becoming rogue worlds wandering the galaxy forever, frozen and lifeless. Others remain trapped, orbiting the black hole that replaced their star, a dead system circling a corpse of gravity. Earth is thrown outwards, a silent, frozen world drifting endlessly through interstellar darkness. Cities preserved beneath ice, oceans locked solid, a tomb carrying the memory of a species that once believed the universe was gentle. Black holes do not hunt, they do not choose, they do not hate. They obey physics, and physics does not care about life. The sun was not special, the solar system was not protected, the universe made no promise that it would last forever. And when the sun met a black hole, there was no explosion, no final scream, no mercy, only silence.